Hello and welcome back to our video series on Java Virtual Machine. In part 1, we discussed the basic JVM architecture and we have seen the JVM architecture consists of several components including the class loader, the runtime data area, the execution engine, the native method interface, the native method libraries. The runtime data area consists of method area, heap, JVM language stacks, PC registers, native method stacks. Today we will be continuing with part 2 of this video series and we will be discussing three main activities that JVM perform, that is loading, linking and initialization, and we'll dive deeper into the class loader subsystem. So let's start discussing loading process. The loading process is responsible for reading the .class file and generating the corresponding binary data. And JVM then save this data in an area of memory known as method area. For every .class file, JVM stores following information in method area. That is fully qualified name of the loaded class and its immediate parent class. Whether the .class file is related to class or interface or enum, and also it store modifiers, variables and method information etc. Once the .class file is loaded, JVM creates an object of type class to represent this file in the heap memory. Please note that this object is type class predefined in java.lang package. This class object can be used by the programmer for getting class level information such as name of class, parent name, methods and variable information etc. To get this object reference, we can use getClass method of object class. Let's see an example. I have created a student class that contains two fields, that is name and roll number. And also I have created getter and setter for this two field. And I have created this test.java class to get information about the student class. Okay, so I have created an object of student class. Now I'll try to create class object. Yeah, so I have called .getClass method from where I get the object of class. Okay, let me print class name. Then c.get. So here we can see we have multiple method to provide information like get name, get package name, get simple name. Okay, so I will select get name. Okay, now we can get many more information. Okay, like suppose we used to write c dot get. Yeah, so as we can see here we have many options to get many information about class. Okay, so I'll try to get all field information. Okay, so this is the method, okay, which will give us all the field includes in that class. Okay, okay, so let's import this field class. Okay, so we can see java.lang.reflect. So from here we can import it. Okay, now let's write for each method. and let's print out the method, this field name. Yeah, so from the this for each method, we can get all the information about the field. So here we have option, okay, like get name, okay. This option, from this option we can print the all the field name. So let me format it, okay. And also we can get all the methods present in our class. So we'll check. Yeah, so this method get declare method will provide the list of method object. Okay, let me import, and again we will use for each. Yeah, let me print all the method. Method dot get name. Yeah, let me save it and let me run it. As we can see, we have printed c dot get name. So from there we get the all information like com dot multithread dot heap dot student, and we got the field name and roll number, and after that we got the method name. So from this we can get many information about the class. As we have seen this example in STS, they are creating a student object and then calling get class method and getting class object, and from that class object we can get many information like class level information, method level information, field level information we can get. And also for every loaded dot class file, only one object of class is created. So that is the loading process. Now we will see the linking process. It performs verification, preparation and resolution. As in verification, it ensures the correctness of .class file. That is, it check whether this file is properly formatted and generated by the valid compiler or not. If verification fails, we get runtime exception. That is java.lang.verify error. And in preparation phase, JVM allocates memory for class variable and initializing the memory to default values. Okay, and in resolution, in this process of replacing symbolic reference from the type with the direct reference, it is done by searching into the method area to locate the reference entity. Now in the last process, that is initialization, in this phase all static variables are assigned with their values defined in the code and static block. This is executed from top to bottom in a class and from parent to child in a class. So as we have seen all these three important steps that JVM perform. So there you have it, all these three activities and the class loading process. I hope you found this video very informative and useful. If you have any question or comment about this part, so please feel free to leave in the comment section below, and please don't forget to like and subscribe my channel for more Java related content. Thanks for watching.